Okay, today's video is going to cover solving systems of rates, and this is a very similar idea to solving systems of really anything where we need to create two equations and figure out where they intersect. This is standard mastery number 8. Before we get into the actual problem, I want to just draw your attention to this formula up here, distance equals rate times time. This is the formula that is commonly used to either find the distance something has gone based on the speed and how long it's gone for that speed, or the speed something is going based on how far it's gone and how long it's gone, or the time something has gone based on how fast it was going and how far it's gone. Right? So this is the distance formula, and it's exactly the same as y equals mx, which you are very familiar with. So here our distance is y, our rate is m, and our time is x. And as we go through, we're trying to figure out this stuff, and we're going to use y equals mx to represent it. Cool? So as I read through this, I'm going to use this highlighter, which I just discovered, to highlight the key information as it relates to distance, rate, and time. So a truck leaves at 12 miles an hour, or at 12 a.m., and travels at an average rate of 20 miles an hour. So here we go. 20 miles an hour, that is a rate, that's why I'm highlighting it. 7 hours later, that is a time, that is why I'm highlighting it. A second truck leaves the garage to catch up to the first one. So this truck leaves at this time, and this time isn't important because it doesn't tell us how long, and that's what this time is representative of over here. This is time of day. We're looking for how long. A second truck leaves and catches up to the first. So this truck leaves, and then this truck catches up. So if this truck catches up to the first one, which is going 20, then it has to be going faster. If truck 2 travels at an average rate, and there we go, if truck 2 travels at an average rate of 60 miles an hour, which is obviously faster than 20, then how long will it take before truck 2 catches up to truck 1? So let's go ahead and get into our steps now. We've got to identify the things that we don't know. The things that you don't know are always going to be the things that it's asking you for. So how long will it take before truck 2 catches up to truck 1? So what do we not know? Well, if we're trying to figure out how long something is going, then we do not know the time, and we also don't know the distance. It did not say anything about how far either of the trucks have gone. So let's go ahead and make the first equation for truck 1. And I'm going to use this color. These are the things that we know about truck 1. So truck 1's equation. What is the distance? We don't know what the distance is exactly, but we know that it's gone the same exact distance as truck 2 because they've caught up to each other. That means that they're at the same distance. What do we know about the rate? Well, we know the rate that it's going is 20 miles an hour. And what do we know about the time? Well, we already identified that we don't know the time. So for x, we're just going to leave as x. So we have our distance, which is y, our slope, which is our rate, or miles per hour, which is our slope, and x, which is our time, and that's how we're using them over here. So what do we know about the second truck? Let's start with distance. Does it say anything about the second truck's distance? No, it does not say anything about the second truck's distance in terms of how far it's gone exactly, but it says that it's a catch-up. Right? So we know that truck 1 and truck 2 have gone the same distance, so we can just say y equals y for distance. What do we know about the speed that truck 2 has gone? Well, it tells us it's going 60 miles an hour. So we know that the rate, or our slope, is equal to 60. And then what do we know about the time? Right? We don't know the time. That's what we're trying to figure out, right? But we know something about truck 2's time. And that was given to us at the very beginning when it said 7 hours later, a second truck leaves. So think about that for a second. If truck 1 leaves, and 7 hours later, a second truck leaves, what can we use here to represent truck 2's time? Well, if truck 1 is x, and it goes x hours, what is truck 2's time? Well, it's kind of based on the time that it's taken truck 1 to go. So if truck 1, for example, goes 10 hours or travels for 10 hours, and truck 2 leaves 7 hours later, how many hours has truck 2 traveled for? Well, 10 leaves 7 hours later, so minus 7 is 3. Okay. So if we don't know exactly what truck 1's time is, what we can say is truck 2's time is truck 1's time minus 7 hours because it's left 7 hours later. So now that we've got the information that we need, we can go ahead and just put it all into an equation. And I'm going to do that right now, and I'm going to use a neutral color to do that. Use this color. So the equation that we're going to use for truck 1 is y equals, our m is 20, and x is x. And this is the equation for truck 1. And then the equation for truck 2 is y equals, m is 60, and x is x minus 7 for truck 2. And now we're not going to distribute this 60 because we don't have to. We'll let the computer do that for us. So now we have y by itself in both of these. We can go ahead and move into the third step, which is to graph them both. I'm going to pull up the graphing calculator. Whoops. Let's go back here. Let's figure out how to get the calculator up. There we go. And now I've got to move this window so that I can see what the equations are. So here we are. I'm going to go to graphing, and then before I start entering in things, I'm going to use the window. Now I'm going to hit the x. Well, what is x? X is our time. So what's the minimum time? 0. You can't go negative time, so we'll just make time 0. What about the maximum time? What can we put in for max? And the more accurate you make your window, the easier it's going to be able to find your value in the table. So think about the time for a second. If truck 1 leaves and this one leaves 7 hours later, then we know that they've had to at least go 7 hours. So it's got to be more than 7 for sure. How much more? We don't know exactly. So let's just estimate it and double 7, say 15, right? And you can always come back and fill this in differently if you have to. We can leave the scale as 1 because 1 unit from 0 to 15 is just fine. Now for distance, or y, well, you can't go negative distance, so we'll make that 0. For the maximum distance, well, we don't know the distance exactly, but there's an easy way to figure out roughly what the distance is. Think about it. If the second truck leaves 7 hours later after the first one, that means that this first truck has been traveling 7 hours before this second truck has left. So we know that for 7 hours, this first truck has been going 20 miles an hour. Well, what's 7 times 20? That's 140. So we can say the distance is at least 140. So maybe 300. And maybe we might have to come back. And then the scale for 1, we don't want to go up 1 unit from 0 to 300. So let's change the scale to about, let's go 20. 20 is a good one. And now that we've got the window kind of set up, let's go ahead now and enter in our equation. So the first equation here is y equals 20x, 20x. And then the second equation is y equals 60, y equals 60, parentheses, x minus 7, parentheses. And those parentheses are huge. Make sure that you put the in parenthesis. Now that they're both in, double check. Good, good. I can go ahead and hit graph. And now when you're looking at this graph, what you can see right away is the point that they've intersected on. It's right here. What is that point exactly? Well, we don't know what it is exactly. We're going to use the table to find that out. In order to make this table process go faster, we've got to estimate what we think the x value they're intersecting on is. So 10 would be, right here. Between here, we can actually use the trace button if we want, right? So we can use this trace button and it traces along this line. So we hit trace and I move this up a little bit and I'm going to get it really, really close to where they're intersecting. Okay, so it looks like they're intersecting pretty close to 10 or 11. So I'm going to go ahead and use 11. So let's go to the table. I'm going to delete this and I'm going to use 11. I'm going to see what happens. So now what we're looking for is the two y values that are the exact same, and we've got to figure out, since there's not 2 here, we've got to figure out, do we go lower x values previous, or do we go higher x values next? Well, the difference between these y values is about 180. Now this difference is about 40. This difference is 100. Oh, this is more than 40. I calculated it wrong. This difference is 60. This difference is 20. So it looks like their smaller value would be good. And then this distance is 20. And then the difference between these two, I shouldn't have said distance, is 40. Okay, so this was 20 here, 20 here. So it looks like it's got to be between 10 and 11. So this actually might be a decimal answer, which makes sense because they said do not round the answer. Alright, well, between 10 and 20, so let me go back to the graph. And since I made a great window, it's really easy for me to trace. So as I get really close here, it looks like I'm at 10.29, and it doesn't look like I've hit the intersection point. 10.5, this looks like it might be right on the intersection point. And then I go off it a little bit. So I'm going to try 10.5 because that looks like it's actually the solution. But I want to verify in the table. So I'm going to just type in 10, and then where's the point? 0.5. And this will change the units in the x to 0.5s. So 10.5, where's the double value? Okay, here it is. So we've found the solution to this. When x is 10.5, both of the y values are 210. So we know that 10.5 is our time, and we know that 210 is our distance. So now I'm going to go back to the problem. I'm going to write that down before I forget it. So 10.25 was our x, and our y was 210. I'm going to go back to the problem, and I'm going to close it out by putting it back into the context of the problem. So what is it asking us for again? If truck 2 travels at an average rate of 60 miles an hour, then how long will it take before truck 2 catches up to truck 1? So we're looking strictly for truck 2's time. Well, x is the time of truck 1. So we know that truck 1 has gone 10.5 hours. And we know that truck 2 left 7 hours later. So how long has that gone? Well, we'll take 10.5 and minus 7. Right? Well, what's 10.5 minus 7 equal? No way I'm taking a chance. Pop that back into the calculator just to make sure. So 10.5 minus 7 equals 3.5. So I know that this truck has gone 3.5 hours. And I can go ahead and type that in, 3.5. Now we're only going to do one example today. So do as best you can using this same exact system, applying it to different numbers. Good luck.